All right, hello everyone. We are back and we are going to keep rolling into bare metal infrastructure part 2. We'll be talking about things like preemptible bare metal and circling back on redfish, which I know was mentioned earlier. Great conversation, so let's keep it going and I'll hand it off to Julia.
Thank you. I guess I kind of want to take a quick step back to where we were talking right before the break, which was auto-scaled bare metal for cloud workloads. And we had a great conversation. We had to kind of cut it a little short because we need to take our break. But I've added a list on the Etherpad, and I just want to say if anyone's interested in continuing discussing the topic, that we have a place where we can add names and we can circle back and try and see if we can create some common workloads or common use patterns or common tooling and make the world a better place. And if there's anything else anyone wants to say about that section, now might be a good time.
I guess on my side, I really did enjoy that discussion, and it's something that I feel like is interesting for us because we do have the same exact pattern and the same exact quote unquote flavor of hardware for everything. So it would make sense for us to be able to shut down machines. I don't know people working in other data centers, but once you hit a certain scale, even if you have cages inside data centers, you get charged based on power draw. So there's a big difference of having, on a Sunday evening where everything is not really getting loaded and you have a bunch of empty hypervisors. So you can shut things down versus, on a busy Monday morning, it's a huge difference.
Or maybe even some way of idling the machine or orchestrating, hey, turn down your processor capacity way down and maybe deprioritize, or who knows?
Yeah. So another really interesting thing, and James Pennick is not here, but he talked about this idea, and I will take zero. Like, this isn't my idea; it's his because I think it's really smart. I'm not gonna take any of the credit, but they were looking at actually using the idle workloads, the idle machines, as serverless systems. So anytime you need to run any serverless workloads, they go on these idle machines because they're not doing anything. And you kind of have this infinitely kind of scalable idle machine pool resources for serverless workloads. And that's probably a good way of using that hardware. I found that really interesting. But
likewise. And someone also pointed out that it would be interesting if they could just automatically replace one of the nodes in the workload if it failed or had a problem. And that seems like kind of the other end of that use case, but it seems like something equally as important. Anyway, our next topic is preemptible bare metal. Use cases for turning unused bare metal into cloud infrastructure, orchestration, and thus ultimately security around doing such things. So I'm wondering, to start off, has anyone considered or explored preemptible instances?
Yes, we've definitely had a look at preemptibles. I've been involved in some of the work trying to get preemptible support into Nova with CERN. And CERN, maybe CERN should talk about aardvark, the aardvark approach. Is that Arnie right in that?
I think so.
Right. So yeah, so we've been working on like a tool called aardvark that's meant to deploy preemptible instances, but this is mostly for virtual machines. It's in a state now. So basically, the way it happens is like you can tag certain projects and mark all instances that are in there can be basically removed in case there's like a request with a higher demand from a different projects. So you can basically fill your cloud, and you have like a fraction of them are instances that run in these preemptible projects. And the moment another VM comes along, the request is basically put on hold. then Arbor comes along, kills some of the instances, makes space for you, and you can launch, and the deployment of your VM continues. We haven't tried this with bare metal instances yet, but it's definitely something that we want to look at, because what happens, at least what we observe, is that usually you buy a lot of physical nodes, and then they're there, but it takes sometimes days or weeks or even months until they're like running the use case that they were intended for. And during that time, at the moment, they're basically shut off, sitting there and waiting for the end user to basically instantiate them and like bring them into their service. So if we could use preemptible instances for this, like you could have something that where you just create an instance that is like pulling off some work from a work queue and chew on this in the days and weeks and months until the final user comes along and say like, hey, I'm now ready to instantiate my service. But the user doesn't need to tell us, just tries to create the corresponding instance, and Arbor comes along and cleans up the preemptible instances and then launches the instance. So this is, from what I understand, we haven't tried this, as I said, with bare metal instances. We have this in certain cells at the moment with virtual machines, and it seems to be working fine. So we basically now fill all the cells like 100%. And then when users create an instance, preemptible instances are killed, the request is put on hold and then continue to be deployed if there's enough space when the callback comes in. But for bare metal instances, that is something that is on our radar to do as well.
I guess the next question from that would be, is there anything that you need or want in order to help facilitate doing something like that? And ultimately, I think the question is open to everyone on this call.
I suppose the biggest blocker, maybe this is an obvious statement for the preemptible workload, is just the amount of turnaround time for the deploy time. That becomes way more critical.
Yeah, I was just thinking exactly this. Also for like the previous point that we had, I didn't mention this, but like the time to deploy a virtual machine compared to the time to like clean and deploy a physical machine is still significantly different. And there's other things that go into this. We have talked about like the resource tracking, for instance. So this is OpenStack specific, but like the time it takes to the system to realize that a physical node is free is macroscopic. And if you say like you want to have instances, bare metal instances that are during the daytime doing this and during nighttime doing this, you lose quite some time to move them from one to the other, which would be much shorter with virtual machines. But like with the ironic, okay, this ironic specific again, but with the API and the integration with Nova, in principle, it should work with bare metal instances just as it works with virtual machines. Probably the failure rate, because it's hardware, is higher. I would expect, at least from my experience, that like creating instances is
oh, do you mean, yeah, the create instance failure rate?
Yes, create instance failure rate is higher, at least in my experience, to like things that Rob was alluding to earlier, or Jaden was saying, like there's different machines, they all behave differently, things change, so that's a little bit different. But I think all the building blocks are there, so I'm really eager to try this out, especially now that we have like Arbor running with virtual machines in various cells already.
Yeah, we have done some work with trying to get like Slurm batch services. So, the batch queue system in Slurm can basically decide I need more space and request the cloud for more space. I guess it's no surprise saying you can use exactly, if you get it working with OpenStack VMs, which we have, then you can do the same thing to get it working with bare metal instances. We tested that out, and it works fine, but the turnaround time basically meant we went back to VMs for doing development.
What we usually have is like we have what we call opportunistic batch. So they're like specific projects that automatically create instances, and they try and try and try. And if there's space, they succeed. And then like once the instance launches, it pulls off work from the queue and just starts working on this. And then, but then they can be killed in case some other, but this is a full manual process. And now with artwork, this becomes automatic.
So we have a great question, Etherpad, and it's not bare metal specific, but would single tenant virtual machine usage be a compromise point?
Yeah, so that's my question. And like, so what I mean by that is, could you just deploy one VM that has all of the resources of the bare metal node allocated to it, and that's the only VM on that hardware node, and you use that to try to make it preemptible. I know it's not truly a preemptible bare metal use case, though.
We've actually been typically, for the workloads that are more dynamic, we've often gone for 2 VMs, one on each NUMA node, to try and get, that seemed to be a better balance of the system, but I think it's a good question. It depends exactly on the workload, as you say, like how bad the hit is.
Well, one of the difficulties I see here, this is also like something that was mentioned earlier, where you turn a empty or free bare metal node into a hypervisor, is like, that's pretty complicated to do. It's not just like you flip it over and then it's a hypervisor. You have to at least, okay, maybe that's like our deployment specific, but you have to do a lot of things. You have to add it to a cell. You have to like register with placement. It has to be discovered. It has to be added to all kinds of databases. All of this can be automated, but at least in our case, it's not fully automated A to Z. So there's still quite some steps that need to be done before a physical node can become a hypervisor.
And
that's a good point.
We're going back to the, I was going to say, maybe we're going back to the previous topic, but we've definitely been doing that to some extent. So in sort of a simplest case scenario, you can actually if the machine is empty, which is a big if, you can move it in the KOB inventory from being a hypervisor to a bare metal node, and then work around the bits and pieces. Because in KOB, you've kind of got the whole machine, the switch configuration, which ones are hypervisors and bare metal compute nodes all in one repository. So it's quite easy to see that in the diff. It's not perfect, but yeah, we've been trying to work on the tooling around that to make that easier.
You can also play some tricks. So one of the tricks that we're playing, for instance, when we need to reinstall a hypervisor. So our hypervisors are also bare metal instances. One of the things that we do when we reinstall them is like it keeps the same everything. So basically, we don't like deregister it from placement or from Nova or whatever. It just keeps the same everything. And so what you could do in theory is basically have the hypervisor registered everywhere, and then basically like move it apart without telling anyone, using it for someone else, and then putting it back. That would like shortcut many of the things, but it's well,
I feel less bad about my plan for that though. Because I was thinking exactly down the same lines, as it's basically registered in both places and it's disabled some of the time, as in it doesn't exist right now. But
exactly.
Boo-hoo.
Yep.
That's definitely an interesting idea. And if you didn't have to necessarily scrub the disks, or you could reduce the pre-provisioned time dramatically, then it could almost become feasible at that point.
You're saying you don't want to scrub the disks between which transition?
If you could, flipping in between workload usage, or if if there was I need to dedicate, this hypervisor's been used, I've moved all the work VMs off, I just want to turn into a folding at home machine overnight or something like that. There could definitely be tooling to kind of help enable some of that.
I think you could save on having to scrub the disks if you use network mounted storage for the virtual machine. I know it's not quite as good because you don't get the high performance of the local disk, but it would save you from having to scrub the local disk.
If you're using SSDs, you can just change the key. The disk
I was going to say, if you've got secure arrays, if you've got secure arrays, it's nowhere near as bad. Which, ironic,
the other option would be if you were really rotating this quickly. This is Rob. If you're really rotating this quickly, you could set up 2 partitions if it was a known thing, and then you could mount one partition for one and one partition for the other, and then you'd be able to swap the machines back and actually keep a high degree of persistence from that perspective. We do something where we just use our in-memory OS, and then we'll mount the disk, and so you can get very consistent behavior. It's not as friendly because you're now constraining people more. But
what I was just kind of thinking about is if we could offer the ability to, I need to boot into this RAM disk so everything I'm doing is basically ephemeral. I may not be touching the disk, and it might be a known thing. And if I'm the same tenant, maybe it's okay. I'm just running a different workload for a little while. And I could actually see that same usage and pattern becoming very powerful for people who need to do like maintenance, or I have super special hardware, I need to run this super special update. And the only way I can really do that is to reinstall an OS or a specific thing to be able to do that.
I like
Yeah, I
that
guess the-
idea of running a RAM disk. Yeah.
So we did do that with Ironic, although it'd be nice to make it a feature in Ironic more properly. So what we did was the dangling port in Neutron that I spoke about before. You can add all of the options to tell it to do the right iPXE, and then use Ironic to power it on. Now that's definitely cheating, but it did do the correct RAM disk boot. But it'd be nice if it was a thing we could request. That's a good point.
I'm kind of wondering if there needs to be an ephemeral, please do this thing temporarily, and we go ahead and actually reconfigure, at least on Ironic's case, reconfigure what we have on record and kind of swap in a new active profile and be able to swap it back and forth. Here's a temporary thing, go do this.
I guess it's surprisingly close to rescue, isn't it? It's just not rescue.
It is.
Yeah, it's an interesting case because I don't think I'd thought very long about the special case of if there's only n workloads, then yeah, if most of them are RAM disk only, yeah, you really do make life easier.
And I really like the idea of suspending, like kind of disabling the compute node. I mean, that, and just recreating it or reprovisioning it or going back to that OS. That seems...
It does work, yeah, it does work quite well. The only problem is upgrade. Unfortunately, the auto pinning logic can be a little bit annoyed by the fact that the old hypervisor exists, because you can go into compatibility mode. But if we ignore that, then it's okay.
I mean, and if someone's just, say, donating their compute cycles because to, say, folding at home or computing decimals of pi or trying to break RC564, then it's a thing that they can run in batches during non-peak load, and just they can come back to it later, or as long as they have those mechanisms to be able to go, I need to kind of start shutting down and save my work. Which is kind of takes us back to the preemptible uses and interactions.
I think highlights the use of the profile, so you can quickly switch from one profile to another.
And I'm not even sure it's necessarily a full reconfiguration that would be useful from at least most operators, because if wiping the disks may not be a thing, and it might be that there's some legitimate use cases for being able to go, I need a temporary OS in this, it's different. Here's how to do it.
There's a lot of use cases for that.
As kind of pointed out, it's very similar to rescue.
I know you're describing what we consider sort of default workflows, where you bounce through an ephemeral OS as part of a workflow control system. Yeah, it's super handy. We use it amazingly a lot.
Now, I guess we did kind of briefly talk about some of the security concerns that might exist with doing such things such as this. Does anyone have specific concerns or worries, or would everyone be thinking something like this would be single tenant, or like the operator of the infrastructure doing it?
Do you mean if a machine switched ownership, that it would be a multi-tenant environment, so the tenanting of that machine could change between who had control of the machine while it was reallocated?
I'm not necessarily thinking of changing tenants. I'm more thinking what would be the security requirements if there were. I guess if we were to support multi-tenancy transactions there, it might be interesting. But I think ultimately, if we're changing tenants, the machine probably always needs to be wiped. I mean, if we could snapshot quickly capture data off the machine and then play it back onto the machine as efficiently as possible, that's probably a whole nother case that could be really rapidly re-provisioned. Just depends on what's already there and how much data has to be moved.
Yeah, it's a data movement. It's not that hard to capture a machine and store it from an ephemeral boot state. Copy the drive and create a copy. That's pretty standard process. And then restoring it's pretty straightforward too. But it can be huge amounts of data to do it, and that can create wire problems. And just the compression time if you're doing real compression. It's okay for a day's reassignment.
What do you mean a day's reassignment?
So if you were trying to do it, the analysis that we've done and when we've done prototyping on this, for example, the use case that we get is before I do an upgrade, I want to make a backup of a system. So you boot into an ephemeral disk, you copy the system off, then you reset the machine. Or, if it's not good, you can reset it back by dropping the disks back in. Just pretty straightforward type stuff. The challenge is that the time it takes to do that, if you're actually going to compress the drive in a reasonable way, if it's a big drive, can be out, over an hour. And in that case, then you don't want to do that for a couple hours of use in the evening, just to secure the system. In a multi-tenant environment, if you're just flipping the system over, right? You can k-exec into a new OS and not even go through a reboot cycle. But so for what I meant from a day's perspective is if I was going to give a machine out for 3 or 4 days, making a full backup of it, utility-wise is reasonable. Conceivably, you could save a lot of time and transfer by storing it on the same disk system. This is the use cases that we've explored. You would actually save the backup on a disk in the same array on the same system, so you don't have to transfer it off. You're just copying it over to another system, and then you could sign it and encrypt it and make it available. Somebody could still delete it. Just depends on how much you trust your operators, your guests in the system.
Yeah, at least in the fully physical world of a decade ago or so, I was doing some similar things in data centers where we would image the running machine and save a copy of it locally to support various fast restoration processes, because playing back a 700 gig database from tape was just a nightmare. And it was pretty bad just going from that to copy on disk.
Right. But the use cases that we see for image-based deploy are typically from CI pipelines where you build one image, you can invest in compressing it so the wire transfer is not that bad, and then you clone that. The idea of doing individual disk cloning, people like to talk about it. It's just the overhead on it has seemed high. The tech isn't hard. Actually, all the tech is there. It's where are you going to store those images? How much time it takes to get them done, type of thing. It's an interesting use case from that perspective.
Has anyone looked at using Blazor for things like reservations in any sort of use case like this?
So I can talk about Blazor. So the Chameleon cloud is using Blazar and has been for several years now. I think it's been running for 5 years. Using Blazar upstream, you can do that with virtual machines. No changes required. However, it relies on host aggregates, which don't play very well with Ironic nodes because Nova host aggregates are based around the Nova services themselves rather than the compute node. And so in Chameleon, I was working on Chameleon in the past. We opted to incorporate some changes that were made by JPipes to change the way the aggregates are managed. But this wasn't approved upstream, and the alternative is to use the placement aggregates. And so this is something that we'd like to get in upstream Blazar, but that's not been done yet, mostly due to the lack of access to a good development environment for this. So it's something that we're hoping to make progress on this summer, as we're working on getting. I think Stig mentioned it in the last OpenDev, on working with Vern to get like a community platform up and running. So yeah, short answer is it can be done, but it needs a bit of work compared to the code that's available upstream.
Now, when you say a bit of work, do you mean just for VMs or for VMs in bare metal or bare metal only?
For bare metal specifically.
Interesting. Is anyone else using Blazor in this case, or this sounds like an interesting opportunity for collaboration?
Yeah, I'm not aware. Yeah, go ahead, John.
Oh, sorry, I was just going to say I do work with Pierre, but we've been working with some other customers as well on looking at Blazor, and I think Pierre's been prototyping some work on preemptables. Pierre, have we got a link to that Coral Reef Cloud presentation that we did together? There's a UKRI in London presentation we did about the plans around this.
Yeah, I don't think we have a public link, but I can share the slides. I'll put them in the Etherpad.
Yeah, I keep meaning to do a blog post on this. We should do. So one of the things, a very common. So I'm going back a little bit, but one of the main things that's causing me to think more about moving from bare metal to hypervisors is we're working with quite a lot of clouds where there's a scientific clouds where there's a resource allocation committee saying that there's this mix that needs to be in this quarter, which is a different mix to the next quarter potentially. So it's actually often it's only quarter on quarter changing what the mix is, and that kind of says what kind of balance you want to have in resources between different scientific communities. Like, you know, these get so much, this other person gets so much. Now there's a whole load of if you try and do that naively, right, you want to use quotas. So you can kind of say, you know, you get so much, you get so much. But that very often the allocation that you have is more temporal. So it's kind of like the amount of time you can have a flavor times, you know, the length it's running. So it's more like a billing restriction rather than a actively running restriction. And generally these clouds are quite high levels of contention because everyone's kind of wanted to do, you know, everyone wants to run more simulations to get their error bars down. So there's always work to do. So effectively, Blazor is kind of an interesting way. that you can kind of visualize who's using your cloud when, and then fight with other people to get the reservation slots. So you can sort of fight into the future about who gets what when. And effectively, most people, but there's a lot of people doing this in spreadsheets right now. It's just Blazar lets you do that in a more sort of API-driven way to say, I get it this week, but Bob over there gets it the next week, whichever, and share it between different people. Anyway, so if you do this reservation carving up, one of the problems you can get is that you get gaps in your schedule. So we really like to fill those gaps with preemptibles, because you've got jobs. If you've got a job system that can sort of proactively create VMs, in fact, actually, the system that we're currently testing this prototype with is exactly the same system Arne, I think, was talking about. Some of the grid PP workloads, they're quite good at spinning up VMs and trying to run relatively short running jobs inside them. So there's ideas of trying to balance the demand profile using that. But really, this is about APIs describing what's already being currently done manually, if you see what I mean.
Kind of.
I gobbled that quite a lot.
So I guess kind of the point of this discussion at this point is that preemptibles are not for the faint of heart. Blazor is also not for the faint of heart. It's more for the full deployment experts that know exactly what they're doing and have that time or those cycles to actually do that kind of resource planning and allocation. As you said, a resource planning committee.
Yeah, I think it's where you've already got external constraints, and this is kind of like so maybe it boils down to actually, I think, a bit of that original conversation we were talking about functions as a service. In order for preemptibles to work, you actually have to have workloads that can make use of preemptibles, and in a way that you can get the machine back again. Because in these clouds where you've got, in the private clouds, you tend to have fixed capacity, and what you're trying to do is get maximum value, in some sense of value, whether it's scientific output or whatever, with it from that fixed capacity. Part of it being that stuff that can run elsewhere could run elsewhere when you're full, for example, right? So you kind of try and get the best fit of resources to where it's running. I guess what I'm trying to say, you need to have the correct back pressures in order for preemptibles to work. And it's not, at the moment, the facilities that we have in OpenStack are kind of in development. So I guess the people that are in the positions where this is interesting to, please reach out and collaborate with the folks that are muddling through at the moment. More of us showing what we're doing will get a more general solution, I guess.
So it seems like we should add another item to the Etherpad where for people to add their names if they're interested in collaborating in this area and on solutions related to preemptibles and handling ephemeral workloads or workloads that need to be able to come up and go away on fairly rapid succession.
Yeah, I think that'd be good.
Is it linked to the stateless versus stateful thing, or there is, as you're running it in a preemptible way, you have, tooling to, I don't know, store the state outside of the cloud or in some form or shape?
Maybe there's two lists. Maybe there's a resource management list and a stateless workload and ironic list.
Seems reasonable.
Yeah, I couldn't work out how to write down what you were saying earlier, Julia, but I think that's a good split.
Well, hopefully people are interested in both.
The evil monkey on my shoulder says that. So, oh, that's another good use case for using the flavor size where the local disk GB is 0, which no one should be using anyway.
I thought that wasn't even saved or used anymore.
No, it's disabled by default now.
Oh, good. Whew.
Or disabled for admins only by default, maybe.
Okay. Well, our next topic is managing your hardware using open standards such as Redfish, which is a dramatic shift from our prior topic. And I kind of want to start the discussion off with a specific question of, are you using Redfish right now? And if we want to, I think it would be good to kind of jump into a discussion of discussing the overall state and perceptions and even pain points if so desired. So we could probably, do we need to do like a quick little informal poll in Etherpad, +1s for Redfish, +1s for still using IPMI, motivation for why?
And both.
What was that? Oh, and both. Ooh.
Yeah, our experiences, there's no uniform. So it's actually IPMI, Redfish, and vendor.
Sorry, you broke up there for one moment.
Sorry. Our experience is IPMI, Redfish, and vendor. So it's actually the truly heterogeneous what we see. I'm just trying to capture the options for both.
So, Rob, are you seeing machines where IPMI no longer works properly, so you're using Redfish?
We're seeing machines that start in IPMI and then transition to Redfish, pretty common, or ones that start in vendor and have to transition to Redfish. Redfish is becoming very popular from what we see, but it's not uniform, and then systems sometimes have to switch back or start in the wrong state, so we can't. It's hard to make assumptions. Like if you switch to UEFI, then that might force Redfish. But if you have to switch back to legacy, then you might not do that. Right?
I think I guess John made a kind of interesting question, which relates to something that we've started seeing some signs of out there, is some of the ways that you have available to say, I want to boot in UEFI mode that are generally cross-vendor compatible via IPMI. The underlying mechanisms are actually being phased out by organizations like Intel. So we're going to start seeing like the ability to say, I need to set these raw flags into the BMC, just disappear. And that's going to make it very painful for people to continue to use IPMI, especially if they want to say, I want to boot my UEFI workload on these IPMI machines. And some vendors have done customized device lists, but everyone seems to approach like UEFI a little differently. And how, like, I know one vendor, you don't even really have an option. It's boot devices as opposed to a general operating mode machine. Also, go ahead.
Oh, sorry. It wasn't that interesting. What I was going to say is I've started to see some boxes shipping with IPMI turned off now by default. So the Redfish being so preferred, the IPMI is actually turned off.
I've started seeing that. I've also started seeing security improvements and changes with like the IPMI command line tool, such that we're starting to see cases where things start breaking with BMC firmware updates, like request retries, or cryptography is one of the more recent ones. So one of the highlight items that a couple of people have brought up is the fact that things are kind of inconsistent. And I think it kind of lends itself to the way Redfish is being approached and the way Redfish exists as a standard. Because when we probably all think standards. We all think there's a specifications document, and the specifications document is fairly specific on what you shall have and is optional. And I think a lot of the issues people are running into right now are largely because the specification is much more about the root endpoint and the basic version data responded and the methods and mechanisms at a higher level, not the actual data points and basically the switches and knobs available via the API. And when you're automating bare metal, it's obviously something where you need those switches and knobs to be consistent or to have the same basic mechanisms across vendors to really support automation. So I'm wondering if anyone has specific pain points that they're encountering, or if they have items that they're curious about, or things that they need or are finding frustrating with it or not.
I mean, something I've had, like I would say, issues with is while Redfish is a nice standard, the implementations vary from one vendor to another. So like in theory, like for example, I had a case, and I think I shared that with you, where it was a specific vendor where the NIC devices would all appear and they would return with the correct MAC addresses when doing inspection using Redfish, but they would all return that their value is down, which meant that Ironic would just ignore them all because they were all like disabled or downed. And there was like no why this was happening. And so that was like a little bit of a struggle in order to be able to get that going. And it's kind of like a big, box that we don't really know it's happening and going in and out, and it's hard to always assume consistency in the Redfish API, other than certain operations that are like the fundamentals. But beyond those, it's very much a wild card of support levels of the API.
Yeah, but there's an interesting thing that we've seen in this is that since the API varies rev to rev, and the implementation sometimes vary rev to rev, even within the same vendor chain, it can be problematic not just across vendor implementations, but even vendor implementations within a series of time.
I've seen cases where across a series of time, vendors have changed names of fields. I've seen vendors indicate that their version is one version and they're leaking in fields and information from later versions of the standard. I've seen the complete reverse of that in different vendors. So I think a lot of it comes down to how people are interpreting the standard when they're actually implementing the DMC features. And I know we as a community probably need to have a cohesive, strong voice and go back to the vendors and try and go, here are our pain points and here are the things that we need. And there is some work going on to try and at least create some standard profiles so that we can at least say there's compatibility with these vendors, or these vendors have certified compatibility through these profiles.
Yeah, we raised this with some Redfish people, so we have the same experience. And there is a certification effort underway, very nascent, to basically be able to test Redfish compatibility to spec. And having that would be useful. Then you could at least confirm everything you described, like things changing names and stuff like that. We've seen also. It's worth noting as a shout out for the Redfish team. This isn't a beat up on the Redfish team.
Oh, yeah, no, it's not. It's definitely, there's a disconnect in between the vendors trying to continue compatibility for things that they've supplied and keep things simple for their users and translate that forward, and also stay compliant with the standard, because the standards, as the DMTF chairs have actually set on a recent Ironic call, the standard's a moving target.
is this something that so we've got an interesting opportunity here. If there's like several open source projects all using Redfish, is it worth agreeing what those projects all agree to be like a very useful minimum bar?
I think there is some ability for that, and I think that I know DMTF would be receptive to that and be willing to accept a profile of like the minimum bar or minimum basic requirements for interoperability or behavior. And I kind of, to take a quick step back, I'm wondering if the compatibility testing was that Rob mentioned, I think, is that the DMTF compliance testing, or is that the actual certification profile work that they're doing?
I believe it's compliance testing. I'm trying to see. Let me look through my notes and see if I can find what that is.
Yeah, I think part of this, where this also gets difficult, is how open that standard is. It's going to end up being, oh, you have a boot object. Awesome, good for you. Not necessarily what's in the boot object.
Yeah. Yeah, it's a hard. I'm looking. Sorry, I'm looking up what.
Oh, no worries.
If I can find it, I'll post it.
Are there, I mean, beyond kind of the weirdness that Mohammed mentioned, was there any other weirdness people are encountering? Sort of things that we could probably work around in software to recognize, oh, that's probably not a big deal, or there's another approach that we need to take?
I think there is a hidden requirement that there is expectation that you have written it for one type of the hardware and you will be able to port it and run it on the other type of the hardware because it's a standard. And I think this is kind of the requirement which we indirectly state. And then when we try to, demonstrate it, that we are bumping into the problem. Partially for, because standard is pretty, pretty young, so there is no, people have not done the full implementation in many cases, or because the interpretation, as you pointed out, or the product releases, change things a little bit, which causes a change in the behavior.
Indeed. I kind of also suspect what we'd still run into is the state matters, and I suspect like the out-of-band inspection indicating that the ports, or ignoring ports because they look down, is probably just because the power's not on for the machine, and so line carrier isn't officially online. So there's probably some slightly different interpretation of how that data gets reported across vendors. I bet another vendor would probably say, well, power's off, but I have line carrier, so I'm good.
Yeah, I mean, in Dell, for example, you can power on iDRAC where the rest of the server is down, so you can configure it the way you want it to. But obviously, the rest of the node will not be functional yet. So, again, it's interpretation of the standard.
Indeed.
Oh,
So,
sorry, need to drop.
Yeah. No, Julia's asking a great question, though. It's what is the feedback for this? I don't know. We struggled with this on the team also because we're influencing the spec wasn't as exciting to us as dealing with machines that show up, and having to fix whatever arrives from a vendor perspective. The best defense I could see is having a way to do a test of any system as part of qualification run. So when we onboard equipment, we'll put it through a pretty exhaustive validation series and test check. Writing something like that for the Redfish spec is going to be hard. There's just a lot of vendor wrinkles.
Yeah, and we even today, we still run into issues where a new firmware version comes out and all of a sudden things are just slightly different. Mm-hmm. And that causes unexpected behavior. Like one vendor made a change to one of the field handling because of a comment that was made in the DMTF document that wasn't saying remove this. It was just basically implying we never intended for this to be the case. So everyone went and ripped out the support. It's like, no, that's not what you're supposed to do on a stable API.
Yeah.
So, yeah. With the number of people still using IPMI, I kind of feel we should probably take a step back and also get an idea of the essential things people are using in IPMI. That way we make sure we have those bases covered, at least as open source projects, for when IPMI starts really becoming broken or vendors say, nope, no more IPMI, so that we can maintain continuity for the users.
Yeah, it'd be really good if maybe this is exactly what you're saying. If we get the Redfish support unified enough to the same level as IPMI when IPMI goes away, when that's the case, I guess.
So I just added a couple of things to Etherpad around line 260. Boot device, whether it's network disk, power on or off, non-masking interrupt. Yes, indicator lights. I guess I should fix up that patch for ironic so that we have it for IPMI as well.
Boot device is boot order from that perspective. We find
I guess
super important, which includes network boot.
Yeah, I guess some of the vendor extensions do allow you to assert order for IPMI.
Yeah, we have a pretty common use case for people that want to be able to come in and say, we're done network boot, switch to disk boot. And then when they realize they need it back, so we need to switch it back.
Yep. We tend to take the I want to do overrides approach, but that's even somewhat problematic on Redfish, because that whole approach starts changing when you go to UFI, and in the schema 1.10 standard, it starts changing again. So.
I was just going to say, I've noticed that when we're doing the overrides, sometimes that's now actually requiring a boot cycle to apply the override, which I'd not seen before. I don't know if other people were seeing that.
I would be really concerned about that. Is it doing it itself, or is... Okay, so
it's you submit a BIOS settings change, and all BIOS settings change now appear to make a boot cycle on some hardware.
Via IPMI?
This wasn't IPMI, sorry.
Okay.
This is using the vendor one.
I think that's also the case in Redfish, because I know
okay, really?
For supporting, with some vendors supporting virtual media, you end up in a case where you actually have to make the attachment and assert the configuration to boot from that device as separate jobs.
Okay.
So people have added graphical console on IPMI. I wonder who's actually like issuing IPMI command line and somehow getting a graphical console, because I apparently need to order some of this hardware.
It's probably the like built-in web server that has access to the console.
Kind of what I was thinking, but it's important to ask.
Yeah, and Supermicro makes a separate like standalone software that interfaces with their BMCs using IPMI or Redfish. That provides like a local graphical interface. As another example.
And I can issue some commands since I've downloaded the Java files. I can issue a few commands and then pop up with the graphical console through the Java applet.
So it looks like we have a fairly complete list. Server sites.
Everything.
Yeah.
No, you don't get to choose. I mean, the thing that's not on this list is really like BIOS configuration, rate configuration, things like that. This is more the utility of, except for the temperature readings piece, is the utility of power on and core ops, which is what the question was, right?
Yeah. Well, basically, how are you using IPMI today in terms of like the IPMI protocol and the related actions that may be supported to make changes to the machine? Because it seems that we should probably endeavor to ensure that we have these same basic things moving forward.
The temperature readings thing sticks out to me because that's a polling data, it's a sort of time series type of information. Is that I'd be interested to see how much people are looking for time series out of band system information as part of a core requirement.
So I and my cohorts worked on some of this work recently, and we see some interest and a lot of interest more along the lines of being able to do alarming for the chassis and collect the data. The conundrum, I think, is when you say, give me all the sensor data on IPMI, you end up with getting a giant blob of data that you have to parse through and return data. With things like Redfish, you end up having to gets against multiple endpoints to kind of hunt down that data. So I think there's dramatic differences in how that data collection needs to perform. And I think like threshold settings, I think that's more up to monitoring systems, especially also like fan speeds, power supplies, input voltages. So our approach on Ironic was at least just present it out to like an exporter or kick it to the message bus via sensor data and just let the operator make those decisions.
We've often come back to that's a monitoring thing, not a control thing. That's why I was asking from that perspective.
It's a great question. Now, go ahead.
No, that's fine.
I just noticed someone added serial ID, like serial number, I guess, which is an interesting item to use across IPMI, but it would be fairly unique considering most BMCs are unique to the motherboards at this point.
Yeah, we use the I think it's a serial ID, but from that snapshot I took, those things in the brackets, those are all the serial IDs for the servers.
Awesome. That was the screenshot of the rack level green or red indicators.
Yeah, exactly.
That was really cool.
Thank you. We can also query, by the way, in those, we have a sensor section and we can get the temperature, voltage, current as well in all from that. So we don't typically do it, but in some cases we have. Like last year, one of the cooling systems went down, and they're like, turn everything off, turn everything off. And so we could watch, and we powered down a few racks, and so from the talks yesterday, I think I'll actually incorporate the temperature settings into the output of this as well, so I can see a 3D temperature of our setup. And we poll every 5 minutes.
Are you just asking the BMC for the SCR data?
Yeah, I think so.
Yeah, that means you probably already have in that blob of data you're getting back.
Yeah, we get it, and we parse through it all.
We do very similar thing with the Prometheus export for Ironic.
Yeah. So yeah, when we query something like the temperature, it just spits back 35 degrees or whatever it's going to be. So
awesome. A few more comments on the Etherpad regarding mixing both IPMI and Redfish. I guess it's much more of a topic that I was ever thinking people were using.
Hello, can you hear me?
Yes, we can hear you. Go ahead.
Hi, this is Jin from China Mobile. I just want to share our experience using both the IPMI and BMC simultaneously. Actually, we just missed the usage of IPMI and Redfish for the server configuration and the check. Like for the server BMC configuration, we use a PSC procedure to load the image to each server. And then our agent in the image will finish the related BMC configuration, like the IP address, gateway, or mask through the inbound BMC driver. And after the BMC got the IP addresses, and then we'll use our automation tool will use the Redfish interface through the out-of-bound network. Yeah, we just use the Redfish interfaces to retrieve some server-specific information, including the MAC address, the hardware component related info. Yeah, this is just our use case. Yeah.
Interesting. I had a thought, and now it's kind of run away with me, and I'm looking at the time and wondering if anyone has anything else to add, because I think we're actually about 15 minutes from wrapping up. Yes, I have a 10-minute-ish warning a few minutes ago, so.
I had one related topic, if it's interesting to people, which is the no out-of-band management at all case, like Raspberry Pis.
Those are fun cases. I know some people are working on enhancing support for such things, at least in Ironic. I guess people. Go ahead.
No, we did actually a bit of work with Pis, because you can get them to Pixie boot pretty reliably, but you do lose out of band. Some people are building some out of band consoles or serial console boards for them. I don't think they're following Redfish or even IPMI. But I was curious for the group if it's something like a Pi with no out of band management, or a NUC, which only has what's that spec? The Intel PC.
Oh. Yeah, the one we had a driver for a long time ago. I can't think of what it's called.
It'll come back to me after the call, I'm sure. I was just curious. We don't have to drive into it, but it's starting with out of band management is something we've spent some time on. And
Yeah.
the pies are fun, crazy, cheap little machines.
Oh yeah.
64. So.
If you happen to have links to these BMC boards people are developing, I think that'd be actually pretty interesting for at least people that are doing development or want to play around with stuff, because if we can extend support to make it easy to do stuff like that, then it spreads the ability to adopt and ability to develop.
Yeah, they're all sort of random. We talked about this. I do a weekly DevOps Lunch and Learn, actually today. When we talk Central, and we had somebody, Federico, actually, who's friendly, and y'all probably know, talked about pies and some of them. We talked about the boards towards the end of it. I'll throw a link.
Awesome, thank you.
Maybe a semi-related thing. I'm wondering if people are wanting to try and integrate the smart PDUs. I know there's I think it was a smart PDU driver to do the power control and then do everything else. But I'm more thinking when you're using the smart, more just to sort of tag them in Ironic. I mean, my current plan is I'm thinking of possibly populating the chassis. Not that we use chassis much, but to try and model that. And it's more just for the monitoring, just so it's easier to get all that information through the Ironic API to link where the power is to the machines.
There has been some discussion of both supporting smart PDUs and vendor native power interfaces. And I think a lot of people want that more for monitoring, but also if the BMC is broken, you really don't want to have to dispatch someone in a data center 500 miles away to go push a button because there's a minimum half-hour service fee charge at an insane amount of money.
It's sort of, I think I've heard it also particularly with the switches. Sometimes you kind of just want to hard reboot the switch that's in a HA pair for the same reasoning. But it'd be interesting if you could model that. I suppose you probably can already model that in Ironic. But
at present, really only one or the other, but the chassis, that is interesting. And that could be really powerful, actually.
In the particular case I'm thinking about are these machines where we've got 4 machines in 2U, where they've actually only got 2 power connectors coming out of them, which is a lot of people are using those just for the density. But yeah, it's interesting when you try and do energy because the board tells you what it thinks it's doing, but the PDUs tell you what the whole chassis is doing across the 2 ports.
Yeah, that makes a lot of sense to at least be able to have some way to correlate it and then track it back, because you have to monitor it. It's not just the PDUs, but you have to monitor, or not the chassis, but you have to monitor the PDUs. You have to make sure that you are accounting for the breaker degradation over the lifetime of the breaker. I know it's what I'm referring to as a really obscure thing, but breakers lose 40% of their capacity over 10 years or something ridiculous, which is why residential breakers, you'll find if you have loads that often peak up pretty high, that suddenly the breakers will start popping without actually you having done anything other than maybe turn on your oven.
My parents had that with their shower, I guess, but yeah, same difference.
I actually had this happen in a giant PDU in a data center once. I was the crazy person that just said, fine, I'm going to change the breaker right now. It was also a production outage because it could no longer take the load of the rack.
I didn't know they degraded over time. That's interesting.
Yeah. Interestingly enough, I think American Express has some insane number of patents because they identified it as their major failure point in their data center. and they developed a lab to actually study breakers and improve breaker design. Amazing what comes out of data centers sometimes. Well, I believe it's, go ahead.
Yeah, I was going to say we are just about at the end of the time for today. I wanted to give Mohammed and you a chance to share and summarize any of the highlights that that y'all appreciated from today's discussion.
Yeah, I can start about this. Yeah, I think we had a really interesting conversation that started with an awesome question that was left by Julia, which is like, hey, how do we define what is hyperconverged, which is a line 65, and we had an interesting discussion on how there's probably some similarities in hyperconverged and edge computing, and there were some parallels to be drawn, and we had some really cool feedback from a couple of different users that were kind of running OpenStack in different ways that they were doing hyperconverged setups. We also talked a little bit about running Ceph and doing hyperconverged Ceph, or kind of when you're running monitors and OSDs all at the same time. So, and also about the maintenance, upgrade, and all the other things that come along doing that. We also had some really interesting sharings from the team at China Mobile, and with regards to their tooling that does all the scanning and everything, and which is really interesting how they have two systems that works either in a centralized or distributed mode, which brought some interesting feedback. And then John also shared a little bit about how Bifrost or KOB uses Bifrost and the ironic inspector flow entirely together. And then we talked about some challenges on why you're not actually automating your system enrollment. And so that was one of the things that brought up some discussions around disk image builder, some discussions around VLANs, and maybe some just older hardware that's just not that easy to work with. And then at the end, I think we wrapped up on an interesting idea of being able to switch workloads from one different profile to another. So you can have a machine that used to be a hypervisor that becomes a that's a hypervisor that becomes a bare metal machine, and vice versa. So those are some really interesting topics that we had discussed today. And what's interesting is there's a few people that listed their emails who are interested in discussing some of those use cases. And so, yeah, it would be good to put in your email in there if that's something that interests you as well.
Agreed. And I've
somewhere around line 205, I guess it is. Is that the?
That's fine.
Yeah, let me.
242, I guess, is maybe the yeah. There are a couple of spots.
Yeah. Yes, and there's 209 and but 242, I'll leave that for Julia to discuss.
So we really got some good energy, I think, going when we started talking about the auto-scaling bare metal cloud workload infrastructures. And it was interesting to kind of not only hear the use case of kind of being able to move things around and changing, but then also the replacement machine that's failed in at least heterogeneous environments. Then we also kind of took that same energy and went into talking about preemptible workloads and trying to somehow utilize your bare metal infrastructure for other things. And largely kind of the big concern or blocker that people have to doing things like this seems to be the time to turn machines around. So it seems like we kind of reached some conclusions of things that could be done, or that not necessarily could be done, but that would be good starting points for these things to be able to be automated or to be usable, and some of the other use cases that could be leveraged around these things. Which we did end up having getting to the point where we're starting to discuss both from the resource management standpoint and from like the stateless workload standpoint, or more being able to support ephemeral workloads. So we have two separate lists of email addresses for people that are interested to kind of keep the discussion going, starting at line 243, and then again at line 249. And then we started talking about redfish, which it was really surprising for me to see the number of people still using IPMI, but it also seems like we're all kind of having some of the same pain points.
Supports my theory that in the technology industry, we never get rid of anything. We only add new things.
It sounds right. And for me, yeah, for at least my standpoint, finding out what people are kind of presently using it for is really powerful, because that gives us an idea of the bar we need to hit, or the things that we need to consider, or make sure that we have support for in order to make everyone's life better, so they don't have to go drive into a data center. And also hearing from people trying to use both at the same time, that seems interesting to me, but I guess it kind of makes sense if there's not parity between the two, or more parity work is needed. And then, well, I was gonna say, then we got talking about some interesting variations on machine management. And I really do want to see if I can make Raspberry Pis do things now.
Cool. Well, thank you for both for moderating and leading the discussion today, and keeping it moving along. This, I think, has been one of our most active OpenDev discussions yet. Tons and tons of notes in the Etherpad too. So that's awesome to see all of that. So Ashley, why don't you wrap it up for us and remind us about tomorrow?
Yeah, that was awesome, everyone. Yeah, so tomorrow, make sure to come back, same time, same place, and we will continue our discussion on networking. And then we'll also do the wrap up tomorrow. So just as a reminder, we do have an Etherpad for tomorrow already set up, and the moderators, Mark Goddard and Ian Joliffe, have already added some content to that. So we're going to drop that in the chat right now. So make sure to go ahead and check that out and add any comments in there, anything you want to touch on relevant to the discussion, so that they kind of know how to direct the conversation tomorrow. And we will see everyone tomorrow.
Yeah. Thanks, everyone.
Thanks.
Thanks, everyone.
Thank you very much.
Bye-bye.
Bye.
See you. Bye.
Bye.